Hello students, I am Dr. Amol Rane. Welcomes you to the course Physics Principles and Applications for FYBSc Semester 1 as per the syllabus of Savitribai Phule Pune University CBCS 2019 pattern. So we are studying Physics Paper 2, Chapter 3, Physics of Molecules. So in the previous lectures, we have studied different types of chemical bonds. What is meant by a chemical bond? What are their different types? So we have also studied the ionic bond in detail with the example of NaCl molecule. In this lecture, we are going to study the covalent bond. So we know that there are different types of bonds. So bonding means the attraction between atoms or ions, and there are several types of chemical bonds depending on the type of forces involved. So we have studied the ionic bond in detail in the previous lecture. So in this lecture we are going to study the covalent bond in detail. A covalent bond is formed when two similar or dissimilar atoms achieve stability by sharing valence electrons between themselves. So as in the case of ionic bond, we have studied that the ionic bond is formed by complete transfer of electron from one atom to other atom, right? Here in the covalent bond, the bond is formed by sharing of electron instead of transferring of electrons, right? And this type of bond can be formed between two similar or dissimilar atoms, right? Whereas in the case of if you see in the case of ionic bond, the bond is formed by two dissimilar atoms. There two dissimilar atoms, they were having different electronegativities also. Here we can see that this covalent bond is formed by two similar or dissimilar atoms. They achieve the stability by sharing valence electrons. So we can say this bond is formed between the two atoms by sharing the pair of electrons between the two atoms. So pairs of electrons may be one pair or two pair or three pair, that we'll see. So this bonding force arises due to the presence of shared electrons. So whenever there are shared electrons between atoms, they will form a molecule, and this type of bond is called as covalent bond. So by sharing these electrons, the two atoms acquire noble gas configuration. So we have seen, as in the case of ionic bonds, each atom try to attain the octet configuration. So we have also studied the octet rule. So each atom try to complete its last shell electronic configuration so that it can achieve the stable configuration or noble gas configuration. So here that noble gas configuration can be achieved by sharing of electrons, right? So it is a win-win situation for both the atoms, that they are both sharing the electrons to each other and they are also attaining the noble gas configuration or inert gas configuration. So by achieving the noble gas configuration, the atom, they get stability also, right? So ultimate aim of any chemical bond is to get the stability of the molecule. The compound so formed is called as covalent or non-polar compound. So we will see the polar and non-polar compounds. So covalent bonds formed between two non-metals. So it is formed between two non-metals, whereas in the case of ionic bond, the ionic bond is formed between a metal and a non-metal, whereas here these bonds are formed between two non-metals. So we can see in the periodic table group 14 to 17 on the periodic table, we can see the non-metals, and the bond is formed between these non-metal atoms. So the atom can share one electron pair or two electron pair or three electron pairs. So they can share up to 3 electron pairs. So if they share 1 electron pair, it will form a single covalent bond. If the two atoms they share 2 electron pairs, then they will form double covalent bond. And if 3 electron pairs are shared between the atoms, two atoms, then they will form a triple covalent bond. So we can give different types of these covalent bonds based on the sharing of electron pairs, right? So each shared pair represent a line in a structural formula, right? For example, in the case of hydrogen bond, so that means in the case of H2 molecule, what we have is a single covalent bond. So we can represent it by only single line, but in many cases we can have double covalent bond or triple covalent bond. So the goal of bonding is to fill the outer energy level and become stable, right? So we can see the ultimate aim any bond formation is to complete the outermost electronic shell and to attain the stability in the atom. So we represent these covalent bonds by using electron dot diagrams. So by using these electron dot diagrams, it is much easier to represent the covalent bond between the atoms, right? So let us see what is the electron dot diagrams. Valence electrons means the electrons in the outermost energy level of an atom. So these valence electrons are important in any bonding, we can say, or all the physical and chemical properties of an atom, they are given by these valence electrons. So if we have valence electrons, these valence electrons, they are only taking part in the bonding, and therefore these valence electrons are important, right? We have the in the atom we have nucleus, and surrounding the nucleus we have core electrons. So these core electrons means their electronic shell configuration, these electronic shells are filled, right, completely filled. Only the outermost shells, they are empty. So these empty outermost shells, electrons there, they form the valence electrons, right? So in the case of hydrogen, we can see, so hydrogen has only one electron. In the case of helium, we have two electrons, and both these two electrons, so this is 1s shell that can have only two electrons. So this helium has attained the noble gas configuration already, right? So these electron dot diagrams show the valence electrons as dots surrounding the chemical symbol, right? The chemical symbol represent the nucleus and all the inner level electrons. So that core electrons, I am saying that core electrons are considered itself in the chemical symbol, right? So we only write the dots for the valence electrons, right? So this electron diagram show only the electrons in the outer energy level of an atom, and these electrons are important because they are only taking part in the bonding, right? All the properties, physical and chemical properties shown by an atom, they are only shown due to these valence electrons, right? So inert gases, let's say helium, neon, argon, krypton, xenon, radon, all these having the outermost shell completely filled, and because of that their physical and chemical properties are completely different than that of the rest of the atoms. And each atom can have different set of valence electrons, and because of that each atom has different we can say electronic configuration as well as physical and chemical properties. Also, if you see in the periodic table, in a particular group, all the atoms we can say have the same electronic configuration, and because of that some of their properties, physical or chemical properties, they may be similar, right? They may show the similar chemical and physical properties because of the same number of valence electrons, right, in a particular group. So these electron dot diagrams are very important to represent the covalent bonds. So in the case of hydrogen, what we have, only one valence electron. In the case of helium, it has two valence electrons and it has attained the noble gas configuration because it has only the 1s shell, and that is the outermost shell which can contain only two electrons, right, and it has already attained that noble gas or inner gas configuration, and therefore these two electrons we represent like this. In the case of lithium, we know it is having 3 electrons, right, so its atomic number is 3, so it has 3 electrons. So out of these 3, 2 electrons are inside the 1s shell and 1 electron is in 2s shell, right. So this 1s shell 2 electrons we consider as core electrons, right. So the nucleus plus this 1s 2 electrons we consider as core electrons, right, and therefore we represent in by symbol Li, and only one electron in the 2s shell, that electron take in the bonding, and that electron we have shown here by single dot. Similarly, beryllium has 4 electrons, right. So out of these 2 electrons are in the 2s shell, right. So these 2 electrons we can show like this, right. So beryllium can form 2 bonds, and therefore we have represented on 2 sides, right. Boron, we know the atomic number 5, so it can form 3 bonds. In the case of carbon, it has 4 electrons in valence electrons, and therefore it can form 4 bonds, and therefore we have represented 4 valence electrons. Similarly, nitrogen, oxygen, fluorine and neon. So in the case of neon, we can see that it has 8 valence electrons, because in the outermost shell it has 8 electrons, and therefore it has attained the noble gas or inert gas configuration, and because of that neon is chemically inert, right, and here it has attained the octet configuration, right, and therefore we have represented by this kind of symbol, right, 8 electrons. So we can represent a particular bond by this electron dot diagram. Let us say this is H2O, that is water molecule. So in the water molecule we have the 1 oxygen atom and 2 hydrogen atoms. We will see the formation of water molecule later in this lecture. So before that, let us see this oxygen has 6 electrons, so they are shown by dots, and hydrogen, each hydrogen has 1 electron, right, so which is shown by cross, right. So here the covalent bond is formed between this O and H and this O and this H, and this bond, so these 2 electrons they are shared by these 2 atoms, right. So these 2 electrons they are shared by this oxygen and hydrogen atom, right. So each hydrogen shares 1 pair of electron with the oxygen atom, right. So here it is shared. So we can represent like this diagram, right. So let us first study the formation of H2 molecule, right. In the case of H2 molecule, it is a covalent bond. So we can see hydrogen atom. So this is hydrogen atom, it has 1 electron only, so its atomic number is 1, so its electronic configuration is 1s1, right. So it has 1 electron, and we can see it has only 1 electron, so we have shown here 1, and it has 1s2 electronic shell, right, outermost shell is 1s, so we need 2 electrons to complete the 2s configuration. Let's say we need 2 electrons to complete the 1s shell, right. So this atom can share its electron and it will attain that noble gas or helium configuration, right. So here one hydrogen atom and another hydrogen atom, they can share the 2 electrons and they form the H2 molecule, right. So here this one hydrogen and this is another hydrogen atom, so both are sharing 2 electrons with each other, and they have attained the noble gas configuration or inert gas configuration. That means it has attained the helium configuration. So we know that helium has 2 electrons and their electronic shell are filled, right? So each atom, each hydrogen atom, its 1s shell will be filled, right? So each atom will be having 2 electrons in the 1s shell when the H2 molecule is formed, right? And therefore the bond become stable. So this is the formation of H2 molecule. We will consider another example of chlorine molecule. So if you see, in the case of chlorine, what we have, each chlorine atom has, so let's say 17 atomic number. So its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5, right? So we can see, in order to complete the octet configuration, we must have 8 electrons in the 3 shell, right? So it has 2 electron in the first shell. In the second shell it has 8 electrons. In the last shell it has 7 electrons. But we need octet configuration, so we need 8 electrons here, right? So this chlorine atom can share its 1 electron to another chlorine atom, and both the chlorine atom, they can attain the noble gas configuration. So we can see here, in the case of Cl2, what we have, right? And when the bond is formed, so each atom is having 7 electron in the outermost shell. So when the bond is formed, their electrons will be shared, right? And Cl2 molecule will be formed, right? So Cl2 molecule will be formed by sharing. So these 2 electrons, or we can say 1 electron pair, is shared between Cl2 Cl atoms, and therefore it is a single covalent bond, right? So this 1 electron pair is shared between 2 chlorine atoms, and therefore this chlorine molecule is again example of, we can say, covalent bonding. So we have considered the example of H2 molecule and Cl2 molecule. Both these molecules, they are having similar atoms, right? So hydrogen hydrogen and chlorine chlorine, they are similar. Now let us consider the formation of HCl molecule. In the case of HCl molecule, what we have, 2 dissimilar atoms. One is hydrogen atom, another one is chlorine atom, right? So we already know the electronic configuration of hydrogen, so it is 1s1, and chlorine, it is we can say outermost shell configuration is 3s2, 3p5, so it has 7 electrons, right? So if this hydrogen need 1 electron and chlorine also need 1 electron, if they share their electrons, then they can form a bond and they can attain the noble gas configuration or octet configuration, and hence they will become stable, right? They will attain the stability by forming HCl molecule. When one hydrogen and chlorine atom, they come closer, they will form bond and they will share 1 electron pair between them, and therefore we can say the HCl molecule will be formed, right? So thus each atom has attained the noble gas or inert gas configuration. So electronic configuration of we can say it will have 2 electrons in the outermost shell, and here the configuration will be 2-8-8, right? So chlorine atom will attain the 2-8-8 configuration. So this is the formation of HCl molecule. So we have considered Cl2, H2 and HCl molecule formation. So we can represent by electron dot diagrams here, right? So here I am only writing the valence electron. So in this diagram we have shown only the valence electrons, right? So chlorine atom has we can say 7 valence electrons. So each chlorine atom has 7 valence electrons, and when they share the 1 electron pair in between them, they can form a bond. So Cl-Cl bond. Then if we count, each atom will have 8 electrons, right? So each atom will have 8 electrons. So here we can share this electron pair, 1 dot and 1 cross, that is shared by this chlorine atom. So it is single bond, single covalent bond. So we represent like this, right? Similarly, in the case of H2, we have one cross and one dot. So dot for one atom and cross for another atom, right? So HH. In the case of HCl, again we can represent like this, right? Now let us consider the formation of larger molecule, that is CH4 molecule or methane molecule, right? Now the electronic configuration of hydrogen, we know that it has one electron, so its electronic configuration is 1s1. In the case of carbon, it has 6 electrons, so atomic number is 6. So electronic configuration is 1s2, 2s2, 2p2, right? So this two shell, second shell, it has 4 electrons, right? So we represent by these 4 configuration. So in order to attain the noble gas configuration, the carbon atom can attain the noble gas configuration by either donating these 4 electrons or accepting 4 more electrons, right? So here we can see the outermost shell, it has 4 electrons. So there are it required 4 electrons. So we know that hydrogen, each hydrogen can have only 1 electron. So we need 4 hydrogens to form bonds with carbon, and therefore the CH4 molecule will be formed, right? So when the CH4 molecule will be formed, then we can say 4 hydrogen atoms, they shares electron pairs with the carbon atom, and thus the carbon atom has attained the octet configuration. So in this diagram we can see each hydrogen has attained 2 electrons, therefore it has attained the helium configuration, right? Similarly, each carbon has got 4 extra electrons, so that therefore it has attained octet configuration. So it has 8 electrons. We can see 1, 2, 3, 4, 5, 6, 7 and 8. So it has attained 8 electrons, and therefore the octet configuration, and therefore we can say the methane molecule is formed, right? So this is one of the example of covalent bonding. So here we have shown the methane molecule. So we can represent by this kind of diagram also. Here only outermost shell electrons are shown. So 1, 2, 3, 4, 5, 6, 7, 8 electrons it has attained, right? In the so this CH4 molecule is formed, right? Here we have shown by electron dot diagram. So we can see 4 cross represent the carbon and 4 dots that represent the hydrogen atom. So this carbon has formed so carbon atom has formed a single covalent bond with each hydrogen atom. Therefore 4 covalent bonds are formed between the carbon and hydrogen atoms, right? So this is the formation of methane or CH4 molecule. So similarly we have the H2O molecule or water molecule. In the case of water molecule, what we have again, oxygen atom. So oxygen atom has electronic configuration. So it has 8 electrons. Its atomic number is 8. So electronic configuration is 1s2, 2s2, 2p4, right? So it has 6 electrons in the outermost shell. So outermost shell we can see 1, 2, 3, 4, 5, 6. So thus it required 2 more electrons to achieve the noble gas configuration. So it can achieve the noble gas configuration or inert gas configuration by taking 2 electrons from outside, right? But here it can share the electrons with hydrogen atom, right? Because hydrogen also need 1 electron and oxygen need 2 electrons. So it can form 2 bonds with 2 hydrogen atoms, and therefore we can say we have 1 oxygen atom and 2 hydrogen atom. They will form the H2O molecule, right? When the 2 bonds are formed between the hydrogen and oxygen atoms, so we form the H2O molecule. So 4 electrons, they are also form pairs. So we can see these 2 lone pairs are form, so we call them lone pair, right? So we have two covalent bonds and two lone pairs in the, and because of this lone pair there is some push in the to the hydrogen atom, and because of that this H2O molecule is not linear in shape, right? So we know that this H2O molecule is not linear, but it has some angle, right? So that angle is nearly 104 degrees. So that angle is formed due to the presence of this lone pair in the H2O molecule. So there are two covalent bonds formed between in the H2O molecule, right? Similarly, we have some covalently bonded compounds also. So we have diamond and silicon. So we know the diamond. So diamond means carbon atom. So we know the carbon atom, each carbon atom needed 4 electrons, or it can share 4 electrons to other carbon atoms, right? And it can attain the noble gas configuration, right? So it can form 4 bonds. So each such carbon atom form 4 bonds with the other carbon atoms, and it can form the diamond structure, right? So we know that the carbon atom can appear in different allotropes. So we have diamond, we have graphite, we know graphene, right? So in the case of diamond, each carbon atom can form 4 bonds with other carbon atom by sharing electrons, 4 electrons, and each atom in the diamond molecule or diamond structure, we can say it is a compound. So in the diamond structure, each carbon atom has attained the octet configuration. Similarly, there is example of silicon. So we will consider the silicon example, right? In the case of silicon, there are total number of atoms. In the case of silicon, we have atomic number 14, right? So there are 14 electrons, 1s2, 2s2, 2p6, 3s2 and 2p2 is the electronic configuration. So electronic configuration, outermost electronic configuration of silicon is similar to that of carbon, right? So it has 2, 8 and 4 electrons. Similarly, carbon has 4 electrons in the outermost shell, right? So this silicon can share these 4 electrons with other 4 silicon atoms, and it can form the silicon structure, right? So let us see, it can share 4 electrons with 4 silicon atoms, nearly 4 silicon atoms, and it can attain the silicon. Let us see the covalent bonding in silicon, right? So in the case of silicon, each atom shares 1 electron pair with the other atoms, and it can attain the stable configuration. Similar to the bonding, we have double and triple covalent bonds, right? When more than one pair of electrons is shared between two atoms, a double or triple covalent bond is said to be formed, right? The double bond is represented by double line and triple bond is represented by 3 lines, right? So here we have, in the case of O2 molecule, what we have, each oxygen shares 2 electrons pairs, right? So we know that oxygen has 6 electrons in the outermost shell, right? So it can share 2 electrons with the other oxygen atom. So thus they will share 2 electron pairs and they will form covalent bond, and that bond is double covalent bond. So you can remember the example of O2 molecule which has double covalent bond, right? In the case of N2 molecule, what we have, in the case of N2 molecule, nitrogen has 5 electrons in the outermost shell. So it can share 3 electrons with 3 we can share, so it can share 3 electrons with other nitrogen atom. So thus in the case of N2 molecule, 3 electron pairs are shared between the 2 nitrogen atoms, and therefore this kind of bond is triple covalent bond, right? Now let us consider the polarity of covalent bonds. A covalent bond may be polar or non-polar depending on the fact whether the electron pair is shared equally or unequally between the two atoms. The covalent bonds are affected by the electronegativity of the connected atoms, right? So, if we have two atoms with the equal electronegativities, then it will form a polar covalent bond, right? And if the two atoms they are having unequal electronegativities, then it will form a non-polar covalent bond. So, let us study the non-polar covalent bond first. Two atoms with equal electronegativities such as hydrogen hydrogen, chlorine chlorine and fluorine fluorine will make non-polar covalent bond. That means when the two atoms they are having equal electronegativities, that means they are of the same compound, right? So, they are of same compound and therefore their electronegativities are similar, and because of that they have formed the non-polar covalent bond. So, both the atoms of equal electronegativities attract the electron pair equally, which is situated exactly at the midpoint of the bond between the two atoms. So, when the electron pair is shared by two atoms, when they are having the same electronegativities, the electron pair is shared equally by the two atoms, so that electron pair will be placed exactly at the midpoint of the two atoms, right? And because of that, that bond is non-polar covalent bond. So, electronegativity means the ability of the atom to attract the electron pair towards itself, right? So, it is the force, that means it is having that force to attract the electron pair towards itself. If both the atoms they are having the same force, right, that means they are of the same type, let us say hydrogen hydrogen, they can apply the same force on the electron pair, and because of that, that electron pair remain in the exactly midpoint. Whereas, if we see the example of polar covalent bond, so in the polar covalent bond, if the bonding atoms have different electronegativities, the bond formed between the atoms is called as polar covalent bond, right? So, here one atom pulls the electron closer to itself. It is because the electronegativities are of the two atoms, they are different, and the atom which is having more electronegativity, it can pull that electron pair towards itself, right? So, the atom which is more electronegative will attract the electron pair towards itself, right? So, that atom that pulls the electron more gets the slightly negative charge, right, and the other atom gets a slightly positive charge develop on that atom, right. So, we can see the example of polar covalent bond. The bond formed in the case of HCl molecule, we can see in the case of HCl molecule, the Cl atom is more electronegative than the H atom, and therefore, electron pair is slightly close to the Cl atom than the H atom. So, due to this, a partial negative charge is appeared on Cl atom and an equal opposite positive charge on H atom. So, here I have shown the electronegativities. So, hydrogen has electronegativity of 2.2, right, and chlorine has electronegativity of 3.16. So, their difference is 0.96, right. That means chlorine is more electronegative than the hydrogen atom, and therefore, when the HCl bond is formed, the chlorine atom will pull the electron pair towards itself, and it will attain slightly negative charge. So, it will attain partial negative charge, whereas the electron pair will be more towards chlorine, and therefore, hydrogen atom will acquire partial positive charge, right. Similarly, in the case of HF molecule also we have the electronegativity difference. So, in the case of hydrogen we have 2.2 electronegativity, in the case of fluorine we have 3.98 electronegativity. So, their difference is 1.78, and because of that this fluorine, so we know that fluorine has highest electronegativity value. So, it is highest electronegative atom. So, it pulls electron pair towards itself, and therefore it will become slightly negative. So it will attain we can say partial negative charge is developed on fluorine, and partial positive charge will develop on hydrogen, right. We can represent this charge by this delta sign, right. So plus delta means it has attained partial positive charge, and here minus delta means chlorine atom has attained partial negative charge. Similarly, in the case of HF molecule, the hydrogen atom has attained partial positive charge, and fluorine atom has attained partial negative charge, right. So this is the example of polar covalent bond, right. Let us see another example in the case of H2O molecule. So we know that in the case of H2O, when the H2O molecule is formed, we have electronegativity difference of 1.24, because electronegativity of oxygen is 3.44. So in the case when the H2O molecule is formed, it will form two covalent bonds, and there are two lone pairs also. So since electronegativity value of oxygen is higher than that of the hydrogen, and the difference is of the order of 1.24, so these electron pairs of both the covalent bonds, they are pulled more towards oxygen than hydrogen. So they will be away from hydrogen, and therefore the hydrogen atoms, they will attain partial positive charges, and the oxygen will develop a partial negative charge. So we say that partial negative charge is double of the partial positive charge of each hydrogen, right, because there are two bonds, two covalent bonds here, right. So this is the example of polar covalent bond. So we can have the bond polarity on the scale. We can have the covalent bond and ionic bond. So sometimes in your mind the question will come, then what is difference between a ionic bond and covalent bond based on the electronegativity, right. So if you see this kind of scale, right, so we know that electronegativity values, they vary from 0 to 4, right. So we know the highest electronegative atom is fluorine, so its electronegativity is close to 4, right, and the midpoint is 2, right. So 0 to 4, midpoint is 2, right. Here in the case of chlorine Cl2 molecule, what we have, both chlorine molecule chlorine atoms, they have similar electronegativities and their difference is 0, and because of that they will be placed on the scale here, right. So they will form a pure or non-polar covalent bond, right. So here non-polar covalent bond is formed between this Cl2 molecule. However, in the case of HF, we can see the electronegativity difference is of the order of 1.78, and because of that this value is 1.78, it lies left side of the midpoint, right, it is still below the midpoint, and therefore this bond is polar. So this 0.4 to 2, we say that bond is polar covalent bond. So it is covalent bond, and if the electronegativity differences are greater than these 2, then we can say such bond as ionic bond, right. So we can see NaCl example. In the case of NaCl, we have the electronegativity differences. So chlorine has electronegativity of 3.16, and sodium has electronegativity of 0.9, and because of that the electronegativity difference is 2.26. So it is greater than 2, and therefore we can say the NaCl has formed ionic bond. So one can easily distinguish between a covalent bond and ionic bond if we know the electronegativity differences, right. So let us study the properties of covalent compounds. The covalent compounds have highly directional properties, right. They are highly directional properties because the bond is highly directional, because the electron pair is shared between the two atoms, right. It is in the midpoint, let's say it is in between the two atoms, and therefore all the we can say all the properties they show are highly directional, right. Then covalent compounds may be solids, liquids or gases, right? At normal temperature and pressure, they exist as gases or liquids. Those substances which have high molecular weights exist as solids. For example, chlorine, its molecular weight is 71, is gas. Bromine molecular weight is 160, is liquid, whereas iodine, its molecular weight is 254, is a solid. So based on the molecular weight also, their state will be different, right? The covalent bonds are as strong as ionic bonds. The covalent compounds have comparatively low melting and boiling points than that of ionic compounds, right? All covalent compounds are electrical insulators because ordinarily no electrons are available for conduction, right? Similar to ionic compounds, here also there are no electrons available for conduction and therefore they are electrically insulators. However, some covalent crystals like those of diamond are excellent insulators, whereas others like germanium and silicon are semiconductors, right? We have considered the example of silicon. So silicon and germanium, they are semiconductors, right? So the conductivities of such conductors can be increased by suitable doping. So one can dope other atoms and one can increase their conductivity by using doping of other atoms, right? Covalent compounds are soluble in non-polar solvents such as benzene and carbon tetrachloride. So they are not soluble in water, whereas ionic compounds, they are soluble in water, right? Here they are insoluble in water, but they are soluble. So non-polar solvents such as benzene and carbon tetrachloride. So in the today's lecture, we have studied the covalent bond in detail. We have also studied different examples of covalent bond, right? We have considered the different types based on the number of electron pairs shared. So accordingly, we can distinguish as single covalent bond, double covalent bond or triple covalent bond. We have also studied the covalent bonds based on the electronegativity differences between the atom, whether they are involving the similar atoms or dissimilar type of atom. Accordingly, we can distinguish the covalent bonds as polar or non-polar covalent bonds. We have also studied the different properties of the covalent compounds. In the next lecture, we will study the next type of bonds, that is van der Waals or molecular bonds, then hydrogen bonding and metallic bonding in detail. Thank you.